Hi, this is Mingxin Sun from TikTok. This is the first time for me attending this conference. I think this hyper conference. Thank you. Probably me is the first talk about using confidential computing in the privacy domain. So usually people talking about confidential computing, trust execution environment in the security domain, protect data in use, protecting data, end-to-end data transit and in use and arrest. But how confidential computing can help the privacy community. So that's why today I'm going to talk about the keywords called verifiability. Meaning how to use the technology to provide a verifiable proof to either the auditor, third party of the security and the privacy guarantees you deployed in your backend. But in this talk, I will go through our internal projects, open source projects, and as a use case. But from the use case, you can see how confidential computing are correlated with the privacy domain. So let's start from a very simple background. We all know AI has transformed how we learn, work, and live. It helps us to automating complex tasks and extracting insights from massive data sets. If you follow the recent news, companies like OpenAI, Anthropic, they introduce health-related features. In one of the OpenAI reports, health is one of the most common ways people use ChatGPT. Based on their de-identified analysis of the conversation, over 230 million people asking health-related questions and wellness-related questions on ChatGPT every week. People are sharing the personal and sensitive health information with the service provider. So the question is how the service provider safeguard our health data, wellness data, arrest, in transit, and process. And it is a challenging industry problem. And also for the end user, we also have another question. How can you prove that you are protecting my health questions and background? So additionally, this is something probably we all know the most powerful AI today, especially large language model, only runs on server class hardware, not on your phone, but which typically means user prompts need to be transferred to the server side, and also the context, for example, your physical exam reports, must be visible to the service provider to be processed. Sometimes acceptable for some use cases, but still challenging with highly sensitive data, like the health data, where we expect the similar protection of the end-to-end encryption. So these are the questions we'd like to answer with the project. And this is a typical workflow of how AI agent chatbot works today. Let's use a healthcare question as an example. The user, we usually ask from the client, send a prompt, like I'm not feeling well with my leg, I have some pains, what should I do? And some relevant context, maybe the physical exam report, sending to the server. And the server was deployed as a cluster globally in the data center, and it could be owned by the service provider, or it could be owned by cloud provider. So it's a hybrid. You don't know where the server is. During the process, there are multiple places that your health information could leak or misuse. For example, the administrator higher privileged the user, a higher privileged admin. from the service provider, they have ability to access the data in the cluster. For example, for good reason, they want to debug, they want to reboot to do some site reliability things. And the algorithm and the model owner, they might use the data for their purpose, like fine-tuning their model or something else you don't know. So even though there will be a term of service, like they will use the AI agent, they will tell you how your data will be used in the service provider, right? And your user consent. But how do you know the service provider keep the promise and doesn't violate the term of service or unintentionally misuse the data? So there are like traditional ways you can invite third-party auditors to come in to look at the code, but my question is there any technical solution to guarantee user data can now be seen by service provider, also provide the non-forgeable proof to remotely attest the privacy and security guarantees claimed by the provider without accessing the backend server. So that's why I want to introduce the confidential computing technologies, which is one of the privacy-enhancing technologies, but the underlying technology is not algorithm-based, it's more like a hardware-based, provided by chip vendor like Intel, AMD, NVIDIA, you call all the chip vendors. They provide the solutions to make sure the data in use, in process, in CPU, GPU is protected, and also provide a remote attestation report. I will talk about that later. So our project, we leverage this technology to have end-to-end secure and third-party verifiable data protection solution in AI use cases. In terms of transparency and verifiability, you have to prove to the user that the code model architecture for audit are the artifacts deployed in production. So the trusted execution environment, confidential computing, is a technology that can help with the issue. It provides the runtime hardware signed attestation report endorsed by the chip vendor, proving that a certain software is executed on or use your particular data. And this report is not forgeable, and you can verify by yourself, or the third-party auditors can also verify without trusting the service provider. And so that's the core part of the trusted execution environment. With knowing this knowledge, our high-level goals of the private Verifiable Compute project is to address privacy, anonymity, and verifiability of using AI for processing personal data. So we use this technology to make sure no one, including platform provider, can see what you send and process in the backend. And we provide a remote attestation report to end user to verify the code executed on the backend and the model as well. So this is a more like detailed design goals. We listed here something like the project must apply comprehensive security practice, protecting confidentiality, integrity, and the complete data lifecycle. And privacy preserving, besides confidential computing, we also need to leverage some other PET, privacy enhancing technologies like artificial privacy and you name it, other technologies to ensure some of the other property is properly guaranteed because confidential computing is not a tool can cover all other PET technologies, right? And we also leverage things like oblivious HTTP, which will anonymize the traffic to make sure the IP identity will not disclose to the service provider. So we also enforcing privacy-preserving debuggability and operations to make sure, although we cannot access to the environment, but it's still providing some kind of debuggability and operation. And by nature, enforcement guarantee, it comes from the technology, the trust execution environment, and the no privilege access is enforced by the software we loaded in the trust execution environment. And besides that, private storage, we observed that in the AI scenarios, not all are stateless. You have to solve the problem like user want AI process your physical exam report, for example, and other stateful information. So we provide the user control key encryption mechanism to make sure your data is encrypted by you and can still be used by the project, by the PVC. And for verifiable transparency, we have code transparency and assurance, verifiable privacy, and remote attestation. All the three parts combined together to make sure the code and the model and the data in the backend can be easily audited and verified without trusting the service provider. So that's how the overall architecture. I will not go into detail today, but some of the main parts, there are four main parts. I just point out, you can look at offline. The first part is anonymized authentication and the routing, and second, private processing and the storage, and third, transparent release, and fourth, verifiable transparency. There are a lot of details I cannot cover in this talk, but give you an overall view of this project. There are a lot of opportunities applying different privacy and security solutions in the whole workflow. So we have these projects, and we need to integrate with the business product, right? So the high level value proposition we have comes on three parts. The first is building user trust. So I would say there's no requirements letting us to apply certain technology to prove your privacy and security guarantee technically, right? So we want to leverage the innovations in privacy domains and privacy enhancing technologies. So to showcase our commitments and the technical advancement to protecting user data in AI processing scenarios. And that's how we can build trust with our users. And the second value proposition we have is to mitigate risks. And some of the product features require to access the sensitive user data to provide better user experience. For example, the product like ChatGPT introduced to interact with you on the health information. So that requires us to have higher bars of protecting user privacy in use. And additionally, the remote attestation parts demonstrate a very good and smooth and streamlined way to let third-party auditor to have confidence of how system work. And the last one, with the two parts, our business can apply this technology to having new business scenarios and the privacy security guarantees by guaranteed by nature and technically enforced. So that's the high-level proposition, and we don't have time to see the demo, but this is a very small demo we're building of just like private, it's like an AI chatbot, but we want to show you how the remote attestation like exactly. So this is a lot of technical things, but left-hand side is a website, and if you look at how the client, the browser interacting with the remote server, you will see there's a attestation report like response from the server, and there will be CPU attestation and GPU attestation containing information of the status of the environment. For example, showing that you are interacting with a trust execution environment, and proving that the software executing in the environment is something something has been audited by someone. So that's a demonstration, and there's more details. And you can see in here we have a GPU attestation come from NVIDIA H100, and those are the hardware model, the issuer, and the more technical things. And last, the project is open source for transparency and verifiability as well. So we open sourced this project end of last year, and nowadays the project support cloud deployment, on-premise deployment, and the hybrid deployment model. So we have the very simple like building and deployment tools you can use, and we have like 1 month release cadence, and all the code is transparent. So you can check out the code in the website. And to sum up, we have the private Verifiable Compute, specifically addressing the AI private processing scenarios. And we are using confidential computing technology specifically to solve the confidentiality of the data in use, as well as the verifiability of the code deployed in the backend. So I will continue improving this project. A lot of features will coming in the following months. Happy to have any comments or questions. Thank you so much.